Hello everyone, this is Steve. We're going to graph an ellipse right now. All of the ellipses that we do in college algebra, Math 121, are going to be centered at the origin. So the center of this ellipse is at 0, 0. And just like the circle, the center is not actually part of the ellipse, it's just used as a reference point. Now, when we draw an ellipse, we kind of use a trick to get 4 points on the ellipse. And the secret to that is looking at the numbers that are underneath the x squared and the y squared in this ellipse equation. So there's a 64 under the x squared and a 49 under the y squared. You think about what are the positive roots of those numbers. So positive square root of 64 is 8, positive square root of 49 is 7. That actually tells you how far to move left and right and up and down to get 4 points on the ellipse, which are also the x and y intercepts of the ellipse. So, because there's a 64 under the x squared, and that square root of that is 8, and since it's under the x squared, we move left and right 8. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And there we get 2 points on our ellipse. Because under the y squared we have a 49, and the square root of 49 is 7. Under the y squared, we move up and down 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, looks good. Now what we can do is we can actually connect the dots to draw our ellipse. So kind of like I do with a circle, even though this isn't a circle, it's an ellipse, I kind of just do 1 quarter at a time. Like that. So there's our ellipse. Now, the 4 points that we actually use to help draw our ellipse are actually the x and y intercepts of the ellipse. So we could say that our x-intercepts for this ellipse are going to be plus or minus 8, 0. And our y-intercepts for this ellipse are going to be 0 plus or minus 7. What else can we do? Well, if you look at this long way across the ellipse right here, there's always a long way and a short way across an ellipse, that's called the major axis. So the length of the major axis is going to be 16 units total. And then if you go the other way across, that's the minor axis, everyone. And in this case, the length of the minor axis is going to be 14 units. Only the endpoints of the major axis are called the vertices. So the vertices are here and here. The other 2 points, the y-intercepts, are not vertices in this case. Only the endpoints of the major axis are the vertices. So the vertices for this guy are going to be, once again, plus or minus 8, same thing as the x-intercepts. All right, what else can we do? Well, we can go from left to right to give our domain. So our domain for this would be -8 to 8. And we can go bottom to top to get our range. So our range would be -7 to 7. The last thing that we might want to tell people about this ellipse is where the foci are. The foci, or foci, whatever you want to call them, are always on the major axis. So they're going to be in the same direction as the vertices. And you find them by looking at the numbers beneath x squared and y squared. And what you do to find the foci is you actually do the bigger one minus the smaller one. So we're going to do 64 minus 49, and that's going to be 15. Then you have to take the square root of that number, square root of 15, and that's how far away from the center along the major axis your foci are going to be. Now the square root of 15 is an irrational number, it's just a little bit smaller than 4. So our foci are around 1, 2, 3, 4, so right around here, just a little bit short of 4 in that direction, just a little bit short of 4 in that direction. If you want to write them as ordered pairs, you'd have to write plus or minus the square root of 15, 0, because they're left and right. Okay, that's pretty much all we can say about this particular ellipse. I hope that helped. Thanks for watching.